Hi everyone, my name is Tasfawna Alamu. I am a senior barley breeder at Ethiopian Stoffa Culture Research. Today, in this video, I will try to show you how to prepare Fieldbook using R. In this, we will cover the following designs: CRD, completely randomized block randomized designs; RCBD, randomized complete block design; lattice, alpha lattice, augmented RCBD, factorial RCBD, and split plot design will be covered. So now we'll go directly to the R studio, and then we'll proceed to see how to prepare the field book for different designs. So we will start with the CRD, or complete randomized design. So before we go that for the data analysis, first we need to load the package agricolae. So we can load the package agricolae by calling library and then put the name agricolae inside the package. So after that, one thing we should do is we define the list of the locations what we have been interested. Since in the experimental design we mostly use multi-location trials, so that we will have more than one locations. In that case, we should prepare a randomization for each location. So in order to facilitate this fieldbook preparation, what I have been doing is a little bit a very small loop analysis. So in this case, first we should define the location. Here we should define or list the locations of the experiment. So here, for example, I only list one location, Bakoji, but we can add more other locations. The locations. So the second one will be, we will prepare a vector or a list file, a list that can serve as a storage for the output from the loop analysis. So in this case, we use the function called vector, and then we define the mode as list, and then the length of this list will be depend on the number of locations what you have been list here. For example, if you list the number of location here is 2, here the length of the location will be 2. So in this the vector function will create for us a list of 2 files that will help us to save our output there. Then we will name this list using the name of the locations, so that we will run this list what we have been produced. So if you see the list what we have been, we'll see that the name of the list will be inside the list will be Bakoji, and it doesn't have any information, so we use them as to store our data. So then we should define here the number of replication. So this is the number of replications depending on our preference. So that here we will use the loop function, that is a for loop. This for loop will be used for us to iterate different times of generate design for the specific experimental design until the total number of locations will be considered. So here, for example, we have from the function we use to develop or to produce the design for the CRD called design.crd. and this design.crd required to produce the design, the name of the treatment, and the name of the number of replication, the seed, and the randomization. The first treatment will be randomized. So this information is required. So in this case, we need to define the number of treatment or the name of the treatment. Here, for example, we can define the list, the number of treatment. If the number of treatment is small, we can define it here, or we can bring from other. For example, let us define the number of treatment here. So TRT, which is equal C. So for example, now TRT1, TRT2, TRT3, TRT4, TRT5, TRT6. So now we define 6 treatments, so you can run, or if you're interested, you can bring the name of the varieties or the name of the treatment from Excel and you can import it. But here, since it is a small number, you can define here the number of the treatments. So finally, we'll provide this all information. We have the treatment here, we have the number of replication here, and then we simply will require only run the loop so that it will produce for us the field book for Bokoji. In this case, as you see, the loop here starts from location. It will subset from the location, it will make it lock, and then after this lock process is the randomization for this is done, then the file produced from the first location will be stored inside this list what have been produced previously, and then it will produce for us. So in order to see how this works, especially you can add additional location, Holata, for example. So now we will do, and then now we will run the analysis. Oh, sorry. So we should load first the package. So we didn't load it. So now we'll go it. So it is gone. So if you try to check what is the output from here, we'll see Fieldbook. Yes, then take it. We have for Bokoji. This is the Bokoji output. And then field book, and then this is for Holata. So now we can take this one to R. We can take it to what you called to Excel, or you can take it to CSV file. So we can save it exactly this output to CSV. For example, if you want to save this file to CSV, you can use write CSV. Then in this part, we'll put the field book and then the build book for Bokoji. But and then the new file name can be field book Bokoji.csv. So now it will take for us the field book, and it will save for us like field book Bokoji CSV. Now we can check it here. The file name here, field book, Bokoji CSV. So here we can open, or we can view it. It will be shown for us here, but we can open it in Excel so that our field book will be saved like this, so we can use and print it for other purposes. Okay, like the same way we can save the field book for Asasa. So this can be done with this one, like Holata, for example. then you can name this again for Holata. That's cool. So like that we'll save this output. Okay, so this is how to prepare Fieldbook for the CRD, and now we are trying to prepare Fieldbook for randomized complete block design or RCBD. So the same thing we'll do is the same system we'll do. We will use a loop, and at the same time here also we list the number of locations what we have been interested to prepare the Fieldbook. Here, for example, Bakwaji, Kofale. And then based on the same thing, similarly in the above one, we use vector to produce the list that will be used for saving our outputs. So here, for example, we will use Fieldbook Fieldbook like that, Fieldbook. Yeah, this Fieldbook. So that this Fieldbook, which we are going to use to store our output, is depend on the number of the location. When the number of locations is 3, it will produce for us 3 lists inside one file. If the number of locations is 2, it will produce for us a single file within the list. So like that, we'll run this one, and then we'll see prepare the same thing, and then we should define also the number of location, the number of replication. Define the number of replication. So after that, here when we see for design preparation of RCBD, we have the function called design.rcbd, and for this design.rcbd we need the information required is treatment, the name of the treatment, and the replication. So we will list the name of treatment here also, like this, because this TRT should be equal to this one. That's why, otherwise it will be make the loop become will provide for us error. So C concatenate. So we'll list the list, for example, genotype 1 or G1, for example, in capital, G1, G2, G3, G4, G5, G6, G7. And at the same time, it's also possible to import the list of the genotypes from other source, from file, and we can use that file. For example, in this case, we can, for example, we can import also the file like that using import file from Excel, and then we'll search for the data. We have this information. For example, here I have the file with the list of the genotypes. For example, for RCBD, we have genotype RCBD here, and then I will bring the name with the name Geno, the file Geno. Then I will open the file. So this file have the list of the genotype and the entry name. So we can use one of it, or the entry name or the genotype name. So here I brought the name Geno. So for the treatment here, I can use Geno and the name genotype. This one is the list of the genotype, so I can use this, and then I will run and I will assign the name trait at the same time, so that now I can use this treatment as a list of the genotype will be here, so that if we use the loop in order to produce the Fieldbook for each location. So we'll start from location Bakoji, and then it will analyze, produce for me the Fieldbook, and then the second one will be, it will take Kofale, and then it will be analyzed for me. So like that, we will produce the field book for this RCBD design. So like we'll do it, and then when you see field book and then Bakoji, we'll see this is the Bakoji site. Then field book will be Kofale. This will be a Kofale for RCBD. This is the plot number, and this one. This is the same thing like I do in the upper part. We can write CSV field book for Bakoji, and the file name will be design or book RCBD, the book Bakoji.csv, and also the other one will be write.csv field book Kofale, and the file name will be RCBD book Kofale.csv. So like that, we will produce and we will save these files to our folders. Okay, the third design will be simple lattice. So simple lattice, this property, as you know, is a square. That is, for example, we will have 3 square, 9 element, or 4 square, 5 square, or 6 square. So the same thing here also, we will define similarly the number of locations. So here now we have one location, for example, Bakwaji, and the same thing will produce the file with a list that can be used to store the output from the design and or the generated from the design function for lattice. So this will be mine, and then we should define the name of the number of replication. Here, if you make it 2, it will be a simple lattice. If you make it here, it will be triple lattice. Here, if R equals 2, simple lattice, or R equal 3, triple lattice. Okay. So in this case, we made it 3 triple lattice. So the number of treatment also should be described here. Describe the number of treatment. Number of treatment or genotype. This can be done one, either you can list here, or as I already done, we can import from the data like that. For example, I will go import data from Excel, and then we will bring the file from the data we have here. This is my data, and then I will choose the genotype for lattice here. Yeah, and then this is lat geno. Okay, here as you see there is variety name, and then this is the treatment name, so we can import it. Okay, then we will define treat as lat geno dollar ምልክት dollar. So we select variety name so that it will be our treatment. So the similarly here is a function we use for generate the lattice design field book is, we call it design lattice, and then here this design lattice require only these two information. One is the treatment and then the rep. We don't need to describe here the block size, because already know if there is a material. In this case only we should provide the function a multiple of two numbers, like the multiplication of a number. For example, 3 by 3, 9, 4 by 4, 16, 5 by 5, 25, 6 by 6, 36. So this should be like that, so that the number should be a multiple way, or t square should be r square, like that. No, not r square, block size k square. It means should be number of treatment, n should be k square, where k is the block size. If the block size is 4, it means treatment number should be 16. If the block size is 5, the treatment number should be 25. So that directly the design generator function will know that the block size is directly from by square root and of the number of treatment. So here now we have 15, 25 genotypes, so we will have 5 by 5 lattice design, and here I put 3 replication, means triple lattice. So like that we will continue. So this DS book is the result from this DS, and we can select only the field book with what we have been interested, and then we save this field book output in each location. When first we for the first location, and then it comes the second location and third location, like that it will loop for us. So now we will run the analysis. What is the treatment? Oh, sorry. Okay, sorry, here I thought it is 25 materials, but here I have a material of 75, so I should subset it, and then I will subset only 1 to 25, so that will be 25 genotype. Yes, so I will run it, then already it generates for me the output. So here I will see the output. I will write the output to my hard disk. So like that I will do CSV. Then the same thing, field book Bakoji, and then the file name will be lattice book Bakoji.csv will be our output. So like that we can do the field book for lattice. And the other lattice design type of design is alpha lattice. So similarly, the alpha lattice is different from the simple lattice or triple lattice, is that in this case it's possible to use the varieties of treatment of a multiplication of two numbers. It doesn't necessarily require squared, like 3 square, 4 square, 5 square, 6 square. It's possible 6 by 5, 13 treatment, 4 by 5, 20 treatment, or 10 by 8, 18 treatment, like that. So this is a little bit more flexible. It can be rectangular or it can be square matrix. So this is a type of design. So in this case also the same process what have been developed here is the same process. And first we should define the list of the location we are interested to produce the field book. And then from based on that we'll produce a vector with a mode list with the length of locations. So this field book file will have a list, and that list will have a length of location. If here we have two locations, this list will have two files. If it is 3, it will have 3, like that, because each file in the list will help us to store the output from each location, so that this will be produced by this. So here, for example, we have only one location, but we can list two locations, like comma. We can add holeta. We can add any asasa. It's possible any location. So based on that, it will produce for us the design. So that here we'll run this, and then here also we should define the number of replication. We can make 2 or 3 location. And the number of treatment here can be defined here, or you can write here directly from this R Studio, like that 1 to 20, I make it maybe 20. Or if possible, I can import the data from my file, like I did previously. Like that, I will go bring the data here, example data. And from here, example data, we have the data called lattice, genotype lattice. Yeah, so here genotype lattice, lattice. Okay, so lattice, it has almost 15 materials. Yeah. So from here, I will define lattice and var name. So this is how much is it is about 75 genotypes. So I need for alpha lattice, we can take a square, for example. Maybe you can take here only the first 20 observations, so that 1 to 20 can be used for generating our design, or 1 to 36, for example. Not 36, 30. Okay, so means here, if it is 30, means we are planning to use 5 by 6 alpha lattice. So this block size will be determined based on these genotypes, the genotype number. Since it is a genotype number 13, it means the block size should be 5. So in this case, we should take care of that. The block size should be smaller than the number of blocks. Should be take care of that, because I can't make this one, for example, 6 and do the analysis, because it will be make error, because the concept is in order to reduce the variability within a block. So in that case, it means we have large number of block but with a small number of block size. So within the block number or block size should be less than the block number. So here I will make it 5, and then the block will be 6. 5 by 6 will be 13 genotypes, or 13 treatments. So here also the similar loop will be performed, and then here the only difference here is we use here the design alpha. Design alpha is a function that will help us to produce the design for alpha lattice. So in this case, the only requirement we'll provide is the treatment name, TRT dot, the number of replication, and the number of block size. Okay, so this block size is already set here. The number of treatments is already set here. So the R is already set here. So it will produce for us. The same thing from this output, we'll extract the book from this output, and then this book will be saved in each location when location 1 is iterated, and then the next one for each location right here will be named. This name will be passed to here, and then this output will be saved on this place. So here we'll run replication, and then this is the number of treatment, this is K block size, then we'll run the output. So as we see here, we'll have a field book, yeah, for for the Bakoji. Yeah, yes, the Fieldbook for Bakoji. Okay, so we'll run here. Sorry, here. Yeah, what is this? Sorry, this is wrong. This is Fieldbook. Then run it. Then this one will be 1, and then run. This one will be for Bakoji only. Then the same thing will run, will produce the output. So this output will have only one observation. That is Bakoji. So now we want to save it in our hard disk so that it can be saved like this. That is Fieldbook, and indexed the Bakoji, and then we'll put the file name here, what called alpha book Bakoji CSV. Then it will save for me as a CSV in my hard disk. Okay, and the next design what we have been interested to see is the augmented design RCBD. So this design has the property that we have a block, the number of blocks. In each block we will have the same number of check varieties in each block, and then in each block we will have different number of new tested varieties. So we'll have 3 categories: check varieties and new treatment varieties, and a number of blocks. So number of blocks can be determined based on the size of the plot and the number of genotypes, so that it will determine that way. So here, for example, in our case, the same thing here as we did above. We will define the location name. Here, for example, I can add Holata. And based on this, we will also produce the Fieldbook file with the number of the list based on the location to store our output from the for loop. So that will do this. And then we will define R means the number of block. So which one is the number of block? So the number of block can be replication of block. The number of block can be based on that. If, for example, I have 100 genotypes, probably in each genotype, in each block, if I am interested to put 20 genotypes, it means I will require 5 blocks. So in that case, I will put here 5 block or 5 rep, and then in each block I will have 23 genotype, because I have also here the check. So this is the number of block, and the new treatment or the new varieties or the new genotype to be tested will be can be defined like this. For in this case 100 genotype. But if you are interested, you can also import from the file like this. For example, import from Excel. The same thing as I did previously. Can select here, can here, and from this we can select the genotype for augmented here, geno aug. Then we can bring here, almost we have around how much observation I have here. I have 94 observations. There are some is repeated. Yes, some of the check is repeated, so it means 94 observations. So if I have 94 observation, it means the new treatment will be I can only use the 90 observation or 94 observation. So new treatment will be geno aug geno Then I will index 1 up to 90. The first 90 genotypes will be considered here. So the case, if it is 90, the best part is 1313. Maybe I can make it this 3 block. In each block, I can put 13 genotypes. So, and then we have 3 genotypes as a check. Also, we should define the checks here, like A, B, C. We can define it. So then we can run it, can run. And then the next component is the for loop, what we have been produced and what have been discussed till now. The function we can use for the producing augmented design Fieldbook is design DAU. So this design DAU require the treatment one means the new treatment, as you see, for example, if you see it, if you see and highlight it, the treatment one is, then TRT1 is check. Okay, so we'll use a check here. And then this the treatment two is the new varieties. So here the new varieties will be new TRT. Then R will be the number of replication, and then the other will not be required. So these 3 informations are required. The first one is the name of the check. The second one is the name of the new variety to be tested. Then similarly to the other, we will save this one as DS, and then from this DS we'll extract the book and save as a field book. Then we'll save this field book in our list file by indicating the name of the locations. So now we can run it. Yeah. So this field book will have this output. So this output we have, for example, for Holata here and for Bokwaji here. So now we can save this output in our disk, in our hard disk. So we can use write.csv command. So here fieldbook.bokwaji. The file name can be augmented book bokwaji.csv, and the other one will be the same CSV. The file will be fieldbook Holata, and the file name will be the same aug book holata.csv. So like that we will save in our hard disk. This is what we are going to do. And the other design what we have been looking is factorial design. Factorial RCBD means RCBD means it's factorial, as you know, it's an arrangement. So we use factorial arrangement with RCBD or CRD, but in this case we commonly use RCBD, so that I will show you the factorial RCBD design. So the same thing, this first component will be the same. First, we should list the number of locations, what we have been interested to be plant our experiment. Then here we'll list, for example, Bokwaji, and also maybe Kofali. Then the second one is the same thing as it's been done above. We will define the list with the name of the locations. So here, so we'll have the field, the list with empty, but with the name of Bokwaji and Kofali. And then the next part is to define the number of replication. The number of replication, this is the number of replication. Can define based on your interest, 3, 2, or 5, anything. And then we should define the label of the experiment of each factors. For example, here factor 1 have 2 labels, factor 2 have 3 labels, factor 3 have 4 labels. So we can define the number of labels here, not the name of the treatment. Here only we put the number of labels, so that here we put the number of labels. So here, then the same loop we use. So in order to develop the factorial design, we use design AB function. So here design AB function require here the n level factors, means we will provide only the level of the factors of each factor. For example, if we have factor 1, 2, factor 2, 3, factor 4, 4. So I already define here factor 1, 2 level, factor 2, 3 level, factor 3, 4 level. So I will give these levels, and then the design produce in each combination, and then produce for me the field book for me. So this one is the combination. That's why I put here the first treatment is a treatment combination with factor 1, factor 2, factor 3. Each factor has its own level. Factor 1 has 2 level, factor 2 has 3 level, factor 3 has 4 level. Then other one requires a number of replication, 3 in this case. And the other one is most important here is defining the number of the type of design. Here we put RCBD, but it's possible to use CRD also, and also Latin square probably. Then we extract this output. From this output we save as ADS. We extract the book, and then this book will be saved as FBook, and this FBook will be saved in the list based on the location what we have been considering. So we will run it, this one. Oh, sorry, this one, because I already ran this, but we didn't run this one. Yeah. So here, the same thing here, I have a function, the output here, as you see. Coffee, we have the float number, we have the block, we have A, the factor A, factor B, factor C, means F1, F2, F3 in this case. So he named it yeah, now that's it. So this is the factor name. So if you are interested before saving, we can also add the name of the factors. If we know this, the name of the factors F1, F2, or if you want nitrogen, phosphorus, something, what you're gonna do is I can add here first call names or names, call names, yeah, the same thing. Especially I can do the same thing, will be continue C plots, and blocks will continue, no problem. And then the first one will be factor 1 here, as it is written there, factor 1, or the other F1. Then if I put here F1, it will give me I can produce, or maybe I can provide this name ABC. This one is ABC, but this ABC can be substituted with the name. This one can be written outside, but in this case it's possible. A means factor 1, B means factor 2, C means factor 3. So similarly we can use this name as a call name, factor 1, factor 2, and factor 3. But probably it's better, maybe the level of factor 1 is put here, factor 1, factor 2, factor 3 here, instead of putting here. But the factor 1 name can be given here also. For example, the name of the factors, you don't know, names, this like this, for example. For example, here I can put the list of the factors, factor 1, factor 2, factor 3. So I can put this, and I can put this one names. Probably it can work for me. Yes. So now this Fieldbook will have okay, yes. So now as you see the Fieldbook, so it give me the book F1, F2. This is call names. Okay. Sorry. No, sorry. Then we will name the call names. Then this one means this output is this book. Then this is already changed. Yes, factor 1, factor 2, factor 3. And then this one can be, this book can be saved here, even if it doesn't require that one necessarily. So this one will be DS book will be saved. So that here I will run. And then when we check it here, you will see the name of the factors for list here, factor 1, factor 2, factor 3. Okay, then finally you can also save the same thing as we did the last one. Then the name is Fieldbook Bakoji. The file name will be factorial book bakoji.csv. The next one will be Fieldbook Kofali. Then the name is factorial book Kofali CSV. So in this manner we can produce and save the output here. Then the final design what we will be consider is a split plot. Similarly, this is the first part of the processes will be the same. We will list here the name of the location by separated by comma, and then based on that we will produce a Fieldbook list file based on the length of the locations. So that will be done. So here Bakoji, and then this will run, and then here we'll define the replication. How the number of replication we need. Yes. And then the other one is main plot. We should define the name of the main plot. Here, for example, let's consider, for example, we have here var1, variety 1, and variety 2 as a main plot. And also you can define subplot as N1, N2, and N3. This is what we need: the replication, the list of the main plot, and the list of the subplot we will require. This is the list of the main plot, and this one is the list of the subplot. So this will be developed, and after that, when we see the first one indicates the treatment in plots, means the main plot, and this one will be the treatment of the subplot. So this is main plot, this is subplot, and this is the replication, and we'll choose the design. Also, the design, other part will be continue the same. So this design is can be RCBD or CRD, any others. And then after we define it, we can run. The same thing will happen. For producing split plot design, we will use design split function. This design split function will produce for us design for split plot design. So that here only it requires the main plot, describe it, and the subplot will describe, and then we'll define the design type, and then from here the same thing, we can give the name of the main plot and the subplot also, because if we didn't give the name for that, we'll see the output. Here we'll produce, and then when we see the output, we will see that this is output. Main plot is var1, var2, var3, subplot is n2, n2. So if we are interested to change the main plot and the subplot using other like that variety, and subplot will be nitrogen, we can make like that what have been previously. For example, here can remove it, call names of this. Here, see, the first one will be continue. Plots, S plots, block will be continue, and then the main plot will be, the name of the main plot will be here like that, names of the main plot. For example, here the main plot name is variety, and the subplot name is nitrogen. So I can add this here, the names. Good. So like that will produce this, and this Fieldbook will have this one. So oh sorry, this one will be DS block, DS book. So here, as we see it, what shows is plots, and then the main plot will be variety, the subplot will be nitrogen. So in this manner, we can produce our Fieldbook. Then finally, from this, we can save this output to our disk, so that we write CSV, and then we'll extract the data from Fieldbook, then Bakoji, and then we'll save the file name with the file name split plot Bakoji book Bakoji.csv will be saved. So like that, we can produce our Fieldbook for split plot design. So in this session, we have seen that how to prepare the Fieldbook for different experimental design using R. And then for this preparation, we use only the library Agricolae all have inside. So that with this, we cover how to produce Fieldbook for CRD, RCBD, lattice, simple lattice and simple lattice and triple lattice, alpha lattice, and also augmented design. And we have seen also factorial design and split plot design. So this is what all I have in this session. So you'll see in another session. Thank you very much.